Waste disposal has become one of the defining challenges of modern civilization. With population growth, urbanization, and the rise of consumer-oriented economies, the amount of municipal solid waste, MSW, generated globally has surged to levels unimaginable a century ago. Landfills remain the most common destination for this waste, even in regions with advanced recycling and incineration systems. While many countries are working to transition toward circular economy models, landfills still absorb millions of tons of trash each year. Some have grown to extraordinary proportions, not only in volume and surface area, but also in the scope of their environmental management strategies. In recent years, many of the world's largest and busiest landfills have begun to integrate gas capture and electricity generation, turning once purely waste disposal sites into contributors to renewable energy portfolios. This video explores the top 5 busiest landfills in the world: Puente Hills, USA, now closed but historically massive; Bordo Poniente, Mexico; Apex Regional, USA; Ghazipur, India; and Jardim Gramacho, Brazil. Examining how they are managed, what environmental technologies they employ, and whether they are capable of generating electrical power from waste gases. Puente Hills Landfill, California, USA. Although closed in 2013, the Puente Hills landfill in Los Angeles County remains a benchmark for what a massive and busy landfill looks like. At its peak, Puente Hills was receiving approximately 13,200 tons of waste per day, serving as the final destination for much of Los Angeles's municipal waste. Covering nearly 700 acres and rising to more than 500 feet in height, it was one of the largest man-made structures in Southern California. The landfill operated for nearly 60 years and accumulated over 130 million tons of waste. Management at Puente Hills was notable for its integration of environmental safeguards. Leachate collection systems, liners, and gas extraction wells were installed to minimize groundwater contamination and to capture methane emissions. Unlike smaller or less regulated landfills in other countries, Puente Hills became an early adopter of landfill gas-to-energy (LFGTE) technology. Methane collected from decomposing waste was piped to an on-site power plant, which generated up to 50 megawatts of electricity, enough to power tens of thousands of homes. This conversion of methane to electricity not only reduced greenhouse gas emissions, but also created a steady revenue stream for the Los Angeles County Sanitation District. Following its closure, Puente Hills has been undergoing a transformation into a public park and recreational space. This adaptive reuse demonstrates how a landfill can evolve from a waste repository into an environmentally beneficial site. Puente Hills' history reflects both the magnitude of waste generation in megacities and the potential for landfills to serve as renewable energy producers. Bordo Poniente Landfill, Mexico City, Mexico. Mexico City's Bordo Poniente landfill was one of the busiest in the world until its closure in 2011, receiving nearly 12,000 tons of waste per day at its peak. The site spanned over 900 hectares, making it one of the largest landfills in Latin America. Its closure was precipitated by environmental concerns, chiefly the uncontrolled release of methane, which contributed significantly to greenhouse gas emissions and the risk of contaminating the surrounding soil and groundwater. Despite these concerns, Bordo Poniente became a case study in the potential for energy recovery after landfill operations cease. The Mexican government partnered with private investors to develop a methane capture system capable of generating electricity. By drilling gas wells and installing collection piping, the project aimed to extract methane from the decomposing waste and convert it into usable energy. It was projected to generate up to 90 megawatts of electricity, though the actual numbers fluctuated depending on gas yield. The landfill also exposed systemic waste management challenges in developing megacities. While Mexico City has made strides in recycling and composting since Bordo Poniente's closure, the site highlighted the dangers of relying heavily on landfill disposal without advanced environmental controls. In the years since, lessons learned from Bordo Poniente have influenced Mexico's national policies on waste-to-energy initiatives. Today, Bordo Poniente remains a symbol of both the environmental hazards of poorly managed waste and the potential for post-closure gas recovery projects to transform liabilities into assets. Apex Regional Landfill, Nevada, USA. The Apex Regional Landfill, located just northeast of Las Vegas, Nevada, is currently one of the busiest operational landfills in the world. Managed by Republic Services, it receives more than 9,000 tons of waste daily and sprawls across 2,200 acres. Apex has become the central disposal site for the booming Las Vegas metropolitan area, which produces massive amounts of residential, commercial, and industrial waste. Unlike many older landfills, Apex was designed from the start with modern engineering standards. It features composite liners, leachate management systems, and extensive methane collection infrastructure. The landfill gas-to-energy system at Apex is one of the largest in the United States, capable of capturing millions of cubic feet of methane daily. The collected methane is converted into pipeline-quality renewable natural gas, RNG, which can then be sold to utilities or used in transportation fleets. This integration of RNG production distinguishes Apex from traditional power-generating landfill gas projects. Instead of only generating electricity on site, Apex processes methane into a versatile fuel that can be distributed widely. In this sense, Apex is not only a disposal site, but also a renewable energy producer feeding into the broader energy infrastructure. Apex also illustrates the economic value of large-scale landfill operations in a fast-growing urban area. By converting methane into a marketable commodity, Republic Services reduces greenhouse gas emissions while creating financial incentives for sustainable waste management. Apex thus represents the dual role of modern mega landfills, indispensable for handling massive waste volumes and increasingly important for renewable energy production. Ghazipur Landfill, Delhi, India. In contrast to highly engineered landfills in the United States, India's Ghazipur landfill is an example of the immense challenges faced in developing nations with rapid urbanization and limited waste management infrastructure. Located in East Delhi, Ghazipur has been operational since 1984 and has grown to over 65 meters in height, often compared to a trash mountain. Receiving more than 2,000 tons of waste daily, it has long exceeded its design capacity. The landfill's management has historically been inadequate, with limited leachate collection and minimal methane capture systems. This has led to recurring environmental crises, including methane-related fires and toxic leachate contamination in nearby water supplies. In 2017, part of the landfill collapsed, killing several people and raising alarms about the risks of unmanaged waste mountains. Efforts have been made in recent years to introduce waste-to-energy facilities that can process part of the municipal waste stream and reduce reliance on open dumping at Ghazipur. The East Delhi waste-to-energy plant, located nearby, has begun generating electricity by incinerating combustible fractions of the waste. However, the landfill itself remains a significant environmental hazard with limited gas recovery. Ghazipur highlights the disparity in landfill management between developed and developing nations. While some of the busiest landfills in the West are energy producers, Ghazipur reflects a more dangerous reality. Waste accumulation without adequate infrastructure can become a threat to human health and safety. Nonetheless, it remains one of the busiest landfills globally due to the sheer volume of waste generated by India's growing population. Jardim Gramacho, Rio de Janeiro, Brazil. For decades, the Jardim Gramacho landfill, located near Rio de Janeiro, was among the largest in the world. Covering nearly 140 hectares, it received over 7,000 tons of waste per day until its closure in 2012. Known as the Gramacho Mountain, the landfill became infamous both for its environmental impact and for the thousands of informal waste pickers, or catadores, who made their livelihood by scavenging recyclable materials from the site. During its operational years, Jardim Gramacho was criticized for its lack of environmental safeguards. Leachate frequently contaminated nearby Guanabara Bay, and methane emissions were uncontrolled. However, following its closure, efforts were made to capture landfill gas and develop energy recovery systems. The landfill gas project was expected to generate approximately 70 megawatts of power, contributing to Brazil's growing renewable energy sector. The landfill also became a cultural symbol, notably featured in the Oscar-nominated documentary Wasteland, which showcased the lives of the catadores. In this sense, Jardim Gramacho represents not just a technical challenge but also a social one, illustrating the complex human dimensions of waste management in developing economies. Its closure marked a turning point in Rio's waste policies, with greater emphasis on recycling and energy recovery in subsequent years. Comparative insights and broader implications. These 5 landfills, Puente Hills, Bordo Poniente, Apex, Ghazipur, and Jardim Gramacho, represent diverse approaches to waste management at massive scales. In the developed world, landfills like Puente Hills and Apex have demonstrated how methane capture and energy recovery can transform waste disposal sites into renewable energy hubs. Projects at Bordo Poniente and Jardim Gramacho highlight the potential for post-closure energy recovery, while Ghazipur underscores the hazards of unmanaged waste accumulation. A common theme across these sites is the increasing importance of landfill gas management. Methane, while a dangerous greenhouse gas, represents a valuable energy resource when properly captured. The busiest landfills in the world are therefore not just waste repositories, but also potential contributors to renewable energy grids. However, the disparity in technology adoption between developed and developing nations remains stark, with safety and environmental hazards persisting in places like Ghazipur.